Okay, this is Superlab 1 and we're looking at the policies that we're putting on these peers connected to these external neighbours. So we've pretty much got all of the policies sorted on the previous screen. There's a couple that slip through which we'll cover. So let's take it from the top then. So here we are on router 1 and we're looking at P1.1 import. Now, of course, P1 is also connected through to router 8, and we would like router 1 to be preferred. So on the import on the routes, we've got the standard eBGP import filter, which we see everywhere. We're marking them as peer routes, and we've got P1 preference, which is a simple thing, sets the preference, local preference to 150, so router 1 is preferred instead of router 8. Now on the export, we don't want any P2 routes. This is relatively logical. Obviously, if one peer is advertised to another peer, then we'll end up being far more transit than we intend to be. The purpose of these lines to the peers is so that our customers can get out to the peer if they're running a service, or to the internet via the peer if that's the way we're going. What we don't want on these private lines here to these peers is transit traffic running through. So no P2 routes export. However, we are exporting the local range, and obviously we're deleting the communities with the wildcard as it goes. So that's P11. For IP version 6, we're going to be setting on the export, the no export route. We really don't want those IP6 routes advertised any further than P1, and so we're going to set that no export on the routes just to make sure. We've got the eBGP IP version 6 import filter, as you'd expect, and we're marking it as peer routes. On the iBGP, we're importing the black hole so that the customers or the peer here can mark a route as needing to be black holed, and we're exporting the next hop self, which is a simple next hop self. It's going to do the IP version 6, it's going to do the IP version 4, and that's router 1 to P1.1. Okay, so let's have a look at router 2. We've got the similar thing with the iBGP. We've got the import the black hole. We're exporting next hop self. Again, it's a simple next hop self. So customer 3.1, here it is in the white at the top here. We're importing the import filter as you'd expect. We're marking it as customer routes this time, and we're also marking customer preferred. Now this is one of those policies that escaped. It's quite a simple one. Set policy options, policy statement, customer preferred, term 1, then local preference 200. And that just means that any route that's coming from that customer will be preferred. So if the same route appears via another path, we want it to go direct to the customer. And that's pretty much the case for all of the customer routes. We've been asked to make sure that they're preferred direct to the customer. We've then got the local range exported, and of course we're cleaning the communities. Okay, so that's router 2 to C3.1. Now let's have a look at router 3. This is also going to a customer. It's C2.1. So very similar to router 2, we're importing the eBGP import filter. We're marking the routes as customer, and we're also marking them as customer preferred in exactly the same way. On export, we're exporting the local range. We're cleaning the communities. And of course, on the iBGP, we're exporting the next hop self, and we're importing the black hole. However, there is a couple of differences here on router 3. If you cast your mind back and remember, router 3 and router 6 are the area border routers to this not so stubby area 1. However, router 5 and router 6 are external ASBRs to DC1. And we had a lot of fun on router 6 where the routes from DC1 were unable to be ranged together, and we had to use some aggregates on router 6 to pretend that they were the RIP that's being ranged together as externals going into area 0, and a similar thing the other direction. So it's related to that, but slightly different. Router 6 and router 3, these routers are actually generating the local range so that the other routers have it to export out. So the local range that we looked at previously was a relatively simple local range. All of the other routers are basically matching the route, advertising it out. But on router 3 and router 6, because these guys are actually generating the range originally, then there's an aggregate there. Set policy options, policy statement, local range, term 1 from protocol aggregate. There's the route filter, and then we accept it. And the reason that I mention router 6's difficulties with data center 1 is that obviously there are some other routes there, and router 6 in some of the commands differs from router 3. But in this, they'll both need this, this range, so they're operating together, router 3 and router 6. The other thing here is router 5. So on to the next one. On the iBGP, we're importing the black hole, we're exporting the NHS. And on the C1.1, which is this customer down here, we've got two differences from the other two customers. The first one is we have this extra policy here called damp aggressive. And then also, customer 1.1 really has a different type of routing. They only want the default and the local. So we'll come to that in a moment. Let's start with this damp aggressive. So damping's on all of these customers, and that's just the keyword damping. You can put that straight in on the BGP. However, set policy options, policy statement. We've got a policy here called damp aggressive. It's the name of the policy. And the term 1 is then damping, which is a keyword, and then the name of what I'm calling a damping set, aggressive. So set policy options damping. Now notice here, this isn't policy options policy statement, but this is literally a keyword right here in policy options. And you can define this damping set. So set policy options damping aggressive, and here we can change the suppression value. So from the top, set policy options damping, name the set aggressive, and put the suppression. Then the statement, set policy options policy statements, damp aggressive, term 1, then damping, and connect the set. And then of course, import on the BGP peer. So there's just this extra level, which if you're not familiar with this technology, is a bit of an unusual thing where you can go straight into policy options and then have this keyword damping. Okay, the second thing about C1.1, which is a little bit unusual, is that it's only getting the default and local. It's the only route that it's asked for. So therefore, we're effectively creating one for it. And because of that, we don't need to have the same type of filtering on deleting all the communities. And here what we're doing is we're typing in the command export remove private. And what that does is it literally just strips out the private AS number. Okay, now we're down to router 6. Router 6 has no external neighbors. Consequently, it's not going to need policies on them, but also it's not going to need the next hop self that you would normally have on a peer. And those are the first 6 of the external peers. And next we'll look at router 7 and router 8.